Let's do some long addition. So let's say I have 22 plus 61. So all we do is we say 1 plus 2 is 3, 6 plus 2 is 8. So your answer is 83. Nice and easy, right? Let's do another one. Let's say I have 52 plus 72. 2 plus 2 is 4, 7 plus 5 is 12. So your answer is 124. Again, nice and easy, right? Okay, let's look at one that has maybe a little twist to it. Let's say I have 19 plus 64. How do I add these together? 4 plus 9 is 13. So you put a 3, but you don't put the 1 here. You put the 1 up here. That's called carrying the 1. Then you do 6 plus 1 is 7, plus another 1 is 8. So you get 83. Let's do another one like that. Let's say I have 27 plus 35. 5 plus 7 is 12, so you put the 2, carry the 1. 3 plus 2 is 5, plus 1 is 6. You get 62. Let's do another one. Let's say you have 423 plus 289. 9 plus 3 is 12, so I write the 2 and carry the 1. 8 plus 2 is 10, plus 1 is 11, so you put the 1, carry the other one. 2 plus 4 is 6, plus 1 is 7, so you get 712. Let's try one that's a little bit more difficult. Let's do 3,765,211 plus 2,967,453 plus 2,411,129. Let's add all these together. So you can do it with more than two numbers, right? In this case, we're using 3, and they're all, 7 digits long. So let's try this out. 9 plus 3 plus 1, that's going to be 13. So you can write the 3 and carry the 1. 2 plus 5 plus 1 plus 1, that's going to equal, I think, 9, right? Yep. And then 1 plus 4 plus 2, that's going to equal 7. Then 7 plus 1 plus 5 is going to equal 13, so I put the 3, carry the 1. Then 6 plus 6 plus 1 plus 1, that's going to be 14, so put the 4, carry the 1. 1 plus 7 plus 9 plus 4 is going to be 21, so you put the 1, carry the 2, and then 2 plus 3 plus 2 plus 2, we add all those up, and you're going to get 9. So your final answer is 9,143,793. So using the exact same rules we use to add small numbers, we can also add very large numbers like this. Okay, let's move on. You can also add numbers with decimals. So let's say you had 100.51, and this is good if you're trying to add up money or something like that, right? Like $100.51, you can think of this as. And then you want to add $52.99, we'll say, and $43.10, and then $8.72. You want to add these together. And if you notice, they all have a different number of digits as well, right? So we have to keep everything lined up. So all the decimals here are all lined up over each other, right? So everything is nicely, placed neatly in its own column. So you want to write it like this, and then we'll just add it up the way we normally do. So 9 plus 1 plus 0 plus 2, that's going to be 12. So you put the 2, carry the 1. 9 plus 1 is 10, plus 5 is 15, plus 1 is 16, plus 7 is 23. So I put the 3 and carry the 2. 8 plus 2 is 10, plus 3 is 13, plus 2 is 15. So I put my 5, carry the 1. And because this is the decimal column, right, I have to put a decimal right there, just below all the other ones. Okay, now we're going to add up the next column. 5 plus 4 plus 1, that's going to be 10. So I put my 0, carry the 1, and 1 plus 1 is 2. So your final answer is $205.32. Again, if you're talking about money. Otherwise, it's just 205.32, right? Okay, so that's how we add using long addition. Let's talk about long subtraction. Let's say I have 27 minus 14. What do I do here? Well, 7 minus 4 is 3. 2 minus 1 is 1. So your answer is 13. That's pretty straightforward, right? If I have 641 minus 520, 1 minus 0 is 1, 4 minus 2 is 2, 6 minus 5 is 1. Your answer is 121. Pretty straightforward, right? But sometimes it's not so straightforward. Let's say I have 57 minus 29. 7 minus 9. Well, hang on. If you try to do 7 minus 9, you're going to get a negative number. How do I place a negative number here in my answer? How's that going to work? So you can't subtract 7 and 9 unless you're okay getting a negative, which we're not okay doing when we do long subtraction. So what I want to do is, instead of doing 7 minus 9, I want to borrow a number from 5 to make this number bigger. So instead of a 5 here, I'm going to make it a 4 because I'm going to borrow 1 from it. I'm going to take that 1, I'm going to put it here in front of my 7. So instead of having like 57, I'm going to have 40 and 17. That's kind of the way this is going to work. So I borrow 1 from the 5 to make it 17, and then that 5 falls to just 4 because I borrowed 1. So 17 minus 9. What's that? Well, that's going to equal 8. And then 4 minus 2 is equal to 2. So 57 minus 29 is equal to 28. Let's do another one, just in case that was confusing. Let's do 364 minus 286. 4 minus 6, again, I can't do 4 minus 6. So I'm going to borrow 1 from that 6 to make it 14, and that 6 is going to turn into 5. So 14 minus 6 is going to be 8. And then 5 minus 8, I can't do 5 minus 8, so I'm going to borrow 1 from 3 to make this 15, and that 3 is going to turn into a 2. So 15 minus 8 is going to be 7, and then 2 minus 2 is 0. You don't really have to write the 0. Your final answer is just 78. Okay, let's do another one. Let's do 96.27. If you want, you can think of that in terms of money, right? $96.27 minus 84.39. So again, 7 minus 9. I can't do 7 minus 9, so I'm going to borrow from that 2 to make it 17, and that 2 is just going to turn into a 1. So 17 minus 9 is 8. 1 minus 3, I can't do that. So again, I'm going to have to borrow from that 6 to make this 1 into an 11, and that 6 is going to turn into 5. So 11 minus 3 is also equal to 8. And then I have a decimal here, right? Because that's where my decimals are. 5 minus 4 is 1. 9 minus 8 is also 1. So your final answer is 11.88, or, if you're thinking of it in terms of money, $11.88. Now, hopefully that makes sense. There's another problem, though, when we do long subtraction. What if the bottom number is bigger than the top number? For example, what if I want to do 24 minus 39? What the heck do I do here? Well, again, 4 minus 9, we said you can't do, you have to borrow. But if you borrow from the 2, then that 2 becomes a 1, and it's like, well, you can't do 1 minus 3, right? Heck, you can't do 2 minus 3. So already we're going to have a problem here, right? So what I like to do is I like to switch the order. So instead of 24 minus 39, I'll do 39 minus 24 instead. Because I can do this, right? 9 minus 4 is 5. 3 minus 2 is 1, 15. So because I got 15, over here, my answer is going to be the opposite of that. It's going to be negative 15. So this is kind of a little shortcut. And it kind of relates to subtracting a number where you're going to get a negative. If you remember back to our lesson on integers, I made the point that if you do something like 4 minus 7 and you don't know what that is, you could just say, oh, we'll just do 7 minus 4. That's 3. So the answer to this must be negative 3. It's that exact same relationship where I'm saying 24 minus 39, I'm not sure what that is. Let's do 39 minus 24. You get an answer like 15, so your original answer must be negative 15. So that's the technique I like to use for long subtraction. It just keeps things really nice and simple. So let's do another example of that. Let's say I have 76 minus 83. So I'm going to switch this to 83 minus 76. Let's do this subtraction. 3 minus 6 I can't do. Let's borrow from the 8 to make it 13. That's going to turn into a 7. 13 minus 6 is equal to 7. 7 minus 7 is just equal to 0. You don't have to write it. So you get 7, which means over here your answer would be -7, just like that. Let's do one more. Let's say I have 211 minus 304. So I'm going to flip that around. 304 minus 211. 4 minus 1 is 3. 0 minus 1 I can't do, so I'm going to borrow from the 3. That's going to turn to a 2, and this will be 10. 10 minus 1 is 9, and then 2 minus 2 is 0, so it's just 93. So your answer over here must be -93. Again, that's the technique I like to use, and I think it makes a lot of sense. Let's talk about long multiplication. How do we do long multiplication? Let's say I have 27 times 6. What you're going to do is you're going to start by saying 6 times 7, which is 42. So you put your 2, carry your 4, and then you say 6 times this 2 is 12, plus 4 is 16. So you do 6 times 7 is 42, 2, carry the 4, and then 6 times 2 is 12, plus 4 is 16. That's how you do that. Let's look at another one. 59 times 3. 3 times 9 is 27, so I write my 7, carry my 2. 3 times 5 is 15, but I have to add that 2, so you get 17, so I'm going to write 17 here. So 177 is your final answer. Okay? Now, that's for some pretty basic questions. What if they get a little bit harder? Like what if I have something like 41 times 23? So I'm going to do 3 times 1, that's 3. 3 times 4 is 12, so I'm going to write my 12. Next, what you're going to do is you're going to write a 0 here. You always do this. You always put a 0 underneath that last number. Then you're going to say, okay, what's 2 times 1? Well, that's 2. And then 2 times 4, that's 8. And now what you do is you're going to add these two new answers that you got, these two new numbers, you're going to add them together. 3 plus 0 is 3, 2 plus 2 is 4, 1 plus 8 is 9. So your final answer is 943. So it's like you do this long multiplication, but then you got to do a long addition as well to get your final answer, which is kind of cool. Let's do another one. Let's say I have 24 times 36. 6 times 4 is 24. So I'm going to put my 4, carry my 2. 6 times 2 is 12, plus 2 is 14. So I'm going to put 14 just like that. Okay, now I add my 0. Don't forget to add your 0. 3 times 4 is 12. So I'm going to put my 2, carry my 1. So this 2 is gone. Now I have a 1. Now I do 3 times 2 is 6, plus 1 is 7. So I put my 7. Now add these together. 4 plus 0 is 4. 4 plus 2 is 6. 7 plus 1 is 8. So your final answer is 864. Okay, let's do another one. Let's say we have 221 times 462. So an extra digit now. We're using 3-digit numbers instead of 2, right? But the same rules are going to apply. So we start 2 times 1 is 2. 2 times 2 is 4. 2 times 2 is also 4. Okay, now we add our 0, and we do 6 times 1 is 6. 6 times 2 is 12. So I put my 2, carry the 1. 6 times 2 is also 12, plus 1 is 13. Okay, now I add 2 zeros. Okay, so you have to add an extra 0 each time. 4 times 1 is 4. 4 times 2 is 8. 4 times 2 is 8. Now we add all these together. 2 plus 0 plus 0 is 2. 6 plus 4 plus 0 is 10. So you put your 0, carry the 1. 4 plus 1 plus 2 plus 4 is 11. So you put your 1, carry the 1. 3 plus 1 plus 4 is 12. So you put your 2, carry the 1. 8 plus 1 plus 1 is 10. So your final answer here is 102,102. So hopefully that makes sense to you and you're able to get comfortable with this and do it without too much trouble. Now let's talk about long division. This is the one that everyone talks about all the time. No one likes doing it. So let's say you're doing 44 divided by 3. Another way of saying that is you could say 44 divided by 3, right? They're asking you what that's equal to. So for long division, you write it like this. 44 divided by 3. How do we do this? Well, first we say, how many times does 3 go into this 4 here, this first number? Well, it goes into that once, right? 3 can only fit into 4 one time. So I'm going to put the number 1 right up there like that. Okay? Now I'm going to do 1 times 3. 1 times 3 is 3, so I'm going to put 3 here. And we're going to subtract. 4 minus 3 is 1. Okay, next thing I'm going to do is bring down this 4, like that. I'm going to ask myself, how many times does 3 go into 14, this number here? How many times does 3 go into 14? So if you start thinking about it in your head, okay, 3 plus another 3 plus another 3 plus another 3, I think it goes in 4 times. So you could say, we're going to put a 4 right there. 4 times 3 is 12, right? You couldn't fit 5 3s in 14 because 5 3s would be 15. That's too big. So you could only fit 4 3s into 14, and that's 12. So now you subtract 14 minus 12, and you get 2. So that 2 there is your remainder, right? You can put an arrow, say R, that's your remainder. So what does that mean? It means that when you do 44 divided by 3, the answer that you get is 14, right? The answer's on top, plus a remainder of 2, and that 2 is out of 3. It's 2/3, right? Or in other words, you could write this as 14.666. It just continues forever. So another way to think about this, again, it was 44 over 3. You could split 44 over 3 up into 42 over 3 plus 2 over 3, right? Because you just add the numerator, you just add the tops. 42 plus 2 is 44. And 42 over 3 reduces to 14. See how that works? So 14 plus 2/3, that's the answer we got. You could figure out just by breaking this up, but that's kind of tricky to think about, right? So we use long division to figure out exactly what those numbers are. But that's the reason why we divide the remainder by 3. We don't just leave it as plus 2, right? Let's look at another example. Let's do 96 divided by 8. So let's set this up. 96 divided by 8. We say, how many times does 8 go into 9? Once. 1 times 8 is 8. We subtract, and you're going to get 1. You bring down the 6. I say, how many times does 8 go into 16? It goes in twice. 2 times 8 is 16. Subtract, you get 0. So the remainder for this one is 0. So that means that 96 divided by 8 is equal to exactly 12. No remainder, no decimal part. It's equal to exactly 12. Okay, let's do another one. Let's say we have 74 divided by 4. So we set it up. 74 divided by 4. How many times does 4 go into 7? Oh, once, right? If that was an 8, it would go in twice, but it's not quite that big, so it only goes in once. 1 times 4 is 4. Okay, so we're going to subtract. You get 3. Bring down this 4. Ask yourself, how many times does 4 go into 34? And at that point, you're kind of doing your like another division question, right? But you can figure out that 4 goes into 34 8 times, and that 8 times 4 is 32. Subtract those, you're going to get 2. So you have a remainder of 2. So your answer here, 74 divided by 4, is equal to 18 plus 2 over 4, which is a half, right? 18 plus a half, you could say 18.5 if you want to say that, right? So that's your answer. Let's do a couple more. What if I do 270 divided by 3? 270 divided by 3. How many times does 3 go into 2? Well, you can't really figure that out, right? 3 doesn't go into 2. So then if it can't go into 2, you take the next number, right? So we use 27 instead of just using the 2. So how many times does 3 go into 27? 9 times, right? 3 times 9 is 27, actually. So 9 times 3 is 27. So when you subtract these, you get 0. Bring down the 0 here. How many times does 3 go into 0? That's what this is. It's 0, right? Well, 3 goes into 0 times, right? So I just put a 0 up there. 0 times 3 is 0. Subtract, you get 0. So your remainder is 0. The answer is 90. So 270 divided by 3 is equal to 90, just like that. Let's look at one more question. We'll do 117 divided by 9. So let's set this up. 117 divided by 9. How many times does 9 go into 1? Can't do it, so you take the next number. So how many times does 9 go into 11? It goes in 1 time, so I put a 1 right there above the 11 in that column. So 1 times 9 is 9. subtract, you get 2, bring down the 7. How many times does 9 go into 27? 3 times, I know that one. 3 times 9 is 27, subtract, you get 0. So the remainder is 0. So your final answer, when you do 117 divided by 9, is equal to 13. That's your final answer.